Imagine a world where your body is defenseless, open to every infection, disease, and injury. Scary, isn't it? Thankfully, we don't live in that world because we have an extraordinary built-in defense network called the immune system. It works tirelessly, like your personal army, always on duty to fight harmful invaders and restore balance when things go wrong. Welcome to the fascinating world of immunology. So, what is immunology? It's the science that studies this incredible defense system, how your body battles bacteria, viruses, and toxins while clearing out damaged cells to prevent disease. Understanding immunology unlocks the secret of your body's most powerful protector. The immune system has two main parts, innate immunity and adaptive immunity. Innate immunity acts as the first line of defense with physical barriers like skin, chemical barriers like stomach acid, and the first responder cells such as macrophages and neutrophils. It also triggers inflammation to recruit immune cells to fight infection. Meanwhile, the adaptive immunity specializes in targeting specific pathogens. B cell produce antibodies, T cell destroy infected cells, and memory cell remember past infection for long-lasting protection. Together, this system works seamlessly to keep us healthy and safe.
Now you are well aware of the basics of immunology. Let's dive further into immunization, or in other words, vaccines. Vaccine can be defined as a suspension of organisms or fractions of organisms that is used to induce immune response in the recipients. There are 6 types of vaccines that I'm going to introduce to you today. The first one is attenuated whole agent vaccine, where living but weakened microbes are used to induce immunity. This type of vaccine can mimic an actual infection and can be used for long-term immunity. The reason behind this is that attenuated vaccines can replicate in the body, hence increasing the dosage so they can act as boosters. Next is the inactivated whole agent vaccine, where the microbes have been killed by using either formalin or phenol. The third one would be subunit vaccines. This type of vaccine uses the antigenic fragments of microbe that best stimulate the immune response, and since subunit vaccines just use a small portion of microbe, they cannot replicate in the recipient's body. The fourth one is toxoids, which basically means inactivated toxins, and these vaccines are directed at the toxins produced by pathogens. It requires a series of injections for full immunity and boosters after several years. The next vaccine is conjugated vaccines, where it is used for poor immune response children like infants. These vaccines use capsule polysaccharide in combination with protein or toxoids. Lastly, nucleic acid vaccines is a new technology vaccine in the immunization field, but the idea is using either DNA or RNA to induce the immunity.
We go for the example of vaccine. First, for attenuated whole agent vaccine or MMR vaccine and varicella vaccine. This type of vaccine offers strong long-lasting immunity and require fewer doses or booster shot. Second, inactive whole agent vaccine are COVID-19 and rabies vaccine. This type of vaccine are safe for most people, including those with weakened immune system as the pathogen death. Next, subunit vaccine like HPV and hepatitis B vaccine use specific part of pathogen, ensuring safety with a lower risk of side effect. However, they often require multiple doses and are complex to develop. While conjugated vaccines such as typhoid and pneumococcal vaccine effectively stimulate immunity in young children by combining weakened antigen with strong one, but they are expensive and tailored to specific disease. Toxoid vaccine like Tdap target bacterial toxin, offering safety and stability but need booster for long-term protection. Lastly, nucleic acid vaccine like HIV DNA vaccine and dengue DNA vaccine. These vaccines are stable, quick to produce, and safe from infection risk. But they face challenges like delivery efficiency and weaker immune response in some cases.
Take a quick journey through the fascinating history. Our story begins in 1796, where Edward Jenner, the pioneer of vaccines, had a bold idea. He used a cowpox to protect against smallpox, testing on a young boy named James Phipps. The result? No smallpox happened. So Jenner's breakthrough laid the foundation for modern immunology. Fast forward to 1885, and here comes Louis Pasteur with the rabies vaccine. By weakening the virus, he created a life-saving treatment, pushing vaccine science to the next level. Jump to the 1955, when JANNAH introduced the polio vaccine, when it followed by SAHRIN oral version in the 1960s. Together, they lead the charge to wipe out polio worldwide. In the 1960s, the first measles vaccine emerged. By the 1970s, it evolved into the combined MMR vaccine protected against measles, mumps, and rubella. The 1980s saw the creation of the hepatitis B vaccine targeting a virus linked to the liver disease. By 1997, the World Health Organization with WHO recommended its use worldwide. Next, come the HPV vaccine in 2006. Gardasil became a game changer protecting against cervical cancer and other HPV-related diseases. In 2019, the first Ebola vaccine, which named Ervivo, was approved, bringing hope to the regions battling deadly outbreak. And finally, in the 2020s, the mRNA revolution. COVID-19 vaccines like Pfizer, BioNTech, and Moderna were developed at lightning speed, providing a lifesaver in a global pandemic.
Shall debunk 3 common myths of vaccine and the success story of vaccination during the COVID-19 pandemic. First, vaccines do not contain ingredients in a harmful amount towards humans. Substances are present in doses far lower than what we encounter daily, making them safe to use. Second, vaccines do not cause autism or SIDS. The infamous 1998 study linking vaccines to autism was retracted for flawed science, and extensive research has shown no connection. Third, vaccine-preventable diseases are not just part of childhood. Vaccines protect without the life-threatening complications of diseases. COVID-19 vaccination story proved this fact. Measures program began in February 2021 with 80% of the population fully vaccinated by October that year. Before vaccination, daily death peaked in mid to July 2021, but by December, fatality has dropped significantly. Peru was the country with the highest COVID-19 death rate globally, increased its vaccination coverage from 25% to 80% in just 7 months. By December 2022, with 92% coverage, death has fallen to 41 per day, a significant improvement. Vietnam saw an even steeper decline, with less than 10% vaccinated in September 2021. Death peaked at 216. By December 2022, 78% have fully vaccinated. The average daily death rate has dropped to 0. This data is clear. Vaccines save lives, reduce suffering, and protect communities. Vaccination is a cornerstone of public health. Therefore, its benefit far outweigh any risk.
Vaccination has been one of the most powerful tools in protecting millions of lives from infectious diseases. From the eradication of smallpox to the fast development of COVID-19 vaccine, it shows how science and technology can transform public health. However, challenges like misinformation, limited access, and the need for better vaccines can remain. Thanks to advancement in biotechnology and computational science, these innovations are paving the way for faster, safer, and more accessible solutions to combat infectious disease. First, let's talk about mRNA technology. This groundbreaking innovation allows for quicker and more flexible vaccine development. Then, there is the role of artificial intelligence or AI. AI is transforming how we identify vaccine target and predict immune response, speeding up the process and making it more efficient. Another exciting prospect is personalized vaccine. This vaccine could be tailored to an individual's unique genetic profile, offering improved efficiency and safety tailored to each person. So, what does the future hold for vaccination? The possibilities are remarkable. Scientists are working on universal vaccine designed to protect against entire families of viruses. We may also see the rise of combination vaccine that protect against multiple diseases in a single shot, reducing the need for numerous injections. Nanotechnology is another promising field. The use of nanoparticle in vaccine can enhance how they are delivered and how well they stimulate the immune system. To sum up, the future of vaccination is bright, driven by innovation and collaboration. Advancements have the potential to not only address existing challenges, but also prepare us for the disease of tomorrow. Don't wait to vaccinate.